The purpose for this video is to walk you through some of the steps for the next activity that we're doing in IED, which will be to assign materials to an object and to look at the physical properties, as well as to run an interference test. This video is not intended to walk you through every single step of the activity, but just simply to clarify what some of the steps mean for you to do so that you will be able to do the activity. So in the first part of the activity, you are asked to pull up your design from your accessories project. Now, I don't have a design up here for the accessories project. So what I'm going to do is I'm actually going to do the second part of the activity first, where we're going to run the interference test. And then partway through that, I'll do the material properties and just kind of demonstrate how that's done. So when you get to the interference test, ideally you're supposed to do the interference test on a model that you created of an assembly from like an earlier project that we did differently from how the curriculum has it done. And so what I'm going to have you do is create like your own like assembly. And so to do that, I have in the directions to do a 2 by 3 by 4 inch prism. And I'm not seeing that exactly the way I want to see it. I'm looking at this from a super weird viewpoint. I want that plane. There we go. Okay, that was really weird. Okay, and so to do a 2 by 3 by 4 inch prism, I'm just going to dimension these at 2 inches, and this will be 3 inches, and finish the sketch. Good heavens. There we go. And then we'll extrude it up by 4 inches. You don't have to do that exactly like that way. Yeah, you don't have to do it exactly that way, but you can do like a 2 by 4 by 3 as long as it's this shape prism. Okay, and then we're going to put a 1 inch diameter hole in it. And so it doesn't matter which face you pick or where you put the hole. Okay, so I'll draw the hole on that face and then make it 1 inch. And of course, the assumption is that like you're able to do that, and then we'll do an extrude cut through that. And your hole can really be anywhere in that prism. Basically, you just need like an object with a hole in it. Now I'm going to start a new sketch in the same design, but I'd like to have, there we go, one of the other planes chosen. And for this, we're going to do a cylinder, but we're going to make the diameter of the cylinder like too big for the hole. So the hole has a diameter of 1 inch. We're going to pick 1.1 inches for our cylinder, and then we'll just extrude that, okay, just to give us a cylinder. Now we need to turn each of these bodies into components so that we're able to move them around. So we'll right click on the bodies and turn them into components, and we will ground the prism. So I should be able to move the cylinder around, but not the prism. Now, the way that I did this, I just kind of grabbed a well, let's do the properties analysis. Okay, so we'll do the properties analysis. I want you to pick one component or body from your design. So if your design was just like a single body design, you didn't have to join anything together, then you're going to pick body. If your design had multiple components to it, then you're going to pick component. You're going to right click on it and choose physical material. And then from the list over here, you are not going to pick glass. You're going to come down to metal and scroll down until you get to brass. Oh, there's brass. Okay. And then what you do is you click and drag it onto the component or the body that you want to be brass. Then go back and right click on it again and choose properties. We have done this before, and I want you to write down for that the density, the mass, and the volume. Now, I was not paying much attention to much of anything here, so So I want you to write down the density, the mass, and the volume for that particular physical material on your sheet. Then click OK. And then go back over here to physical material. Again, I want you to right click on the brass and unassign and delete, and then change it to glass. And repeat that process with it as glass. Okay, now I'm going to go ahead and unassign that because I'm not going to take you guys through that. And then the third part of that was to like kind of pick the ideal material for whatever your design is. So if you did like a phone case, probably the 3D printed plastic was not ideal. And then run the materials analysis again on your ideal material. Now for this, we are going to, I have to move and copy this because mine is oriented the wrong way. Whoa, woo. Okay, so I think that's where I want it oriented. Let me kind of look at it again. Okay, yeah, mine was oriented the wrong way, so I want to like move that. You can kind of move it to about where you want that joint to be. The closer you can line it up, the easier the joint is going to be. And now we'll click in the assemble. We're going to do a joint. We want to capture the position. Otherwise, it's going to return my cylinder to like that wrong orientation. And then in your joint menu, I want you to pick a slider joint. So when I go to pick the first object, I'll pick the cylinder. And you can see where I'm like kind of sliding it here. That's called your joint origin. And that just tells the computer where it's going to slide into. And then I will pick my second object and I would like it to slide into the joint. And it's going to go ahead and slide it into the joint and give me that preview of what that looks like. Now, because it's grounded, I should be able to move it back and forth. Now, remember, though, that we intentionally made the diameter of that cylinder bigger than the diameter of the hole. And so Fusion is not registering that it shouldn't fit into that hole. So if you try to build this in real life, it wouldn't work. And so what we're going to do is run an interference test, because while we intentionally did that, sometimes there are designs that you might do where you don't intentionally have like an issue with it, but like you do. And so the interference test is going to figure that out for us. So we are going to capture that position. Okay, and then it asks us to select the two bodies. So we're going to do the cylinder and the prism, including coincident faces. That just means you're going to include the face as part of it. And then you click right here where it says compute. And what it tells you is that these are actually overlapping each other. There's an interference there of about 5,405 cubic milliliters. And if I slide that out of the way, it'll actually highlight where those are interfering. And that tells you that this design, like it can look great in Fusion, but it's actually not going to look great. And so what you guys are going to need to do is run that interference test yourself. I am going to see if it will let me open up. I actually don't know if it's going to let me. I know what I'm looking for. I'm actually looking for a design I did of a picture frame, but I don't think it is going to like just like let me find what I'm looking for. Design samples. Nope. It's a picture frame I did where I had an assembly where I designed a frame using the sweep feature, which we did when we made the, I don't remember what it was, but I know we did the sweep feature. Oh, it was the water pipe. And then I had the glass, which was a separate component, and I wanted to put the glass into the frame. And where I was picking my joint origins, which are those things that like look like those little puzzle pieces when you're doing the joints, I was having a really hard time putting the joint origins in the right spot. And so my glass was constantly overlapping with my frame. And I would run this interference test and it would show that even though the measurements were right for it, it wasn't fitting in like in the Fusion model. Like I wasn't getting it in the right spot. And so that's what an interference test can do. So hopefully this video will help anybody who is absent from class keep up with the material and be able to complete the activity on your own.